This lesson is partial fraction decomposition, and this is for case number 2. Partial fraction decomposition has 4 cases. For our class, for this video, we're going to focus on case number 2. Okay, so again, partial fraction decomposition, there are 4 cases. We're going to focus on case number 2. And case number 2 is when there is distinct and repeat. What is distinct? Distinct is when you have a real solutions, when you have a solutions, and that solution is repeated. Okay? So here is our original equations. You have x minus 2, x minus 3 squared. So distinct is when it is factorable, when there is a solution. One more time. Distinct when the denominator is factorable and the denominator has a solution. That's what distinct is. Repeat means that you're going to have to do this one right here twice. Not once, but twice. Why twice? Because this is square. So since it is distinct, you're going to write A, B, and C because it's distinct. Okay? You will use A, B, C. So A is for first denominator, B is the second denominator, C will be the second denominator again, but with a square. So that's what repeat means. Okay, so one more time. A is for the first denominator, which is x minus 2, B, which is the second denominator, but one time only. And then C is the second denominator again, but square. Okay, but square. Okay, so that's why it is repeat. First power, second power. Okay, if this was third power, then it will be D all over x minus 3 to the third power, and so on. Okay, so again, A is for the first, this A is for x minus 2. B is x minus 3 to the first power. C is x minus 3 to the second power. Okay, so this right here is repeated, but this is first power, this is second power. Okay, if this was a third power, then it will be D all over x minus 3 to the third power, and so on. Okay, so this is the setup. Again, this was the original equation. This on the right hand side is the setup. Okay, now to get rid of the denominators, you're going to collect all of the denominators. Whatever you have here, just put them outside. Okay, so one more time, we're trying to get rid of all of these denominators. Gotta get rid of all these denominators. So use this denominator right here as my common denominator. One more time, we're trying to get rid of these denominators. So to get rid of them, we use this one right here on the left side. We use the one on the left side. That will be the common denominator. So put it outside. Now all you have to do is just multiply them individually. Distribute them. This times this. As you can see, the denominator disappeared. This times this, denominator disappeared. You just have x squared. This times over here, the x minus 2 is gone, but I still have x minus 3 squared. Same thing over here. This times this. One of the x minus 3 disappeared, but I still have another x minus 3. Don't forget the x minus 2. And then finally the C, x minus 3 squared completely disappeared, but I still have x minus 2. Okay, so one more time. This times this whole thing disappeared. I just have x squared. This times over here, x minus 2 disappeared, but I have x minus 3 squared. Now multiply to this, multiply to this. X minus 3 disappeared, but there's a square, so that means there are 2 of these. So only one of them disappeared. So that's why I still have another x minus 3. And don't forget the x minus 2. This times over here, the x minus 3 squared disappeared, but I still have x minus 2. Okay, so be very careful of getting rid of the denominators. Next, multiply this right here, FOIL, distribute. So x minus 3 squared is x squared minus 6x plus 9. Again, there are 2 of these, So FOIL this out, so become x squared minus 6x plus 9. FOIL these out, so I have x squared minus 5x plus 6. And there's nothing to do with this one, leave them alone. Next, you want to multiply a to all of these, b to all this, and c to this. So just distribute completely all the way through. So a times x squared, a times negative 6x, a times negative 6x, a times plus 9, b times x squared, b times 5x, b times 6, and then c times x, c times 2. Okay. Next, we're going to gather all of the x squared together. Gather all of the variable that has x squared. Okay. Gather all of the x squared. So there's one here, there's one here. So that's the first group. So again, we're going to gather all of the variables together. Common variable. So x squared together. My x, here's my other x, here's my other x here. And then the one with no x, this guy here, and also here, go over here. One more time, we're going to gather all of the common variable together. Common variable. So x squared here. X here. No x here, here, and here. Okay. And then don't forget, as always, bring down these guys. Now if you look very carefully, I have x squared, I have x squared term, I have x term, and I have 1 term. Okay. No x term. So x squared, 1x squared, x squared term, x term, no x term. However, on the left side, I have an x squared. I do not have a 0. I do not have an x term. Here I have an x term, but over here I don't, so I have to add them in. Here I don't have anything, so that's just a constant, so add that in. One more time. Whatever the right side does, the left must do the same. One more time. Whatever the right does, the left must do the same. So here I have x squared, here I have x squared, so we're good to go. Here I have x, but over here I don't have an x, so add in. Always add in. If you're missing something, add in. Here I have an x, here I don't have an x, so add in 0x. Here is just a constant with no number, so this guy is for this one. Okay, so one more time. This x squared and this x squared, we're good, so don't worry about that. Here there's an x, but there's no x here, so I have to add in 0x. Over here, this is a constant, so just 0. Okay, and sometimes it's not always 0. It could be 1 with no variable. Okay, so x squared, x to the first power, x to the first power. No x. Okay, so one more time. X squared, so we're good to go. 1x, x to the first power, no x to the first power, so put the 0x in. No x, so there's no other number, so just 0. Okay, so that's how you will replace them. Okay, so it has to be in order. X squared, first power, and then the constant. So x squared, first power, constant. One more time. X squared, first power, constant. X squared, first power, constant. Whatever the right does, the left must do the same. Okay, so one more time. X squared, first x to the first power, x to the first power. Constant. Okay, so now we're going to regroup them again by the terms. X squared term, go with x squared term. So a plus b. Here there's only 1 because there's a 1 right here. Think of it, there's a 1 right here. There's a 1. Here, first power, so that's right there. First power here, there's no number, so 0. Constant will be here. Constant is also 0. So if you're missing a term, then you must put a 0 in. Here I have x squared, I have x squared, so we're good to go. Here I have first power of x, x to the first power, but here I don't, so I have to add it in. Over here I have a constant. There's no constant here. As you can see, the original was x squared. There's no constant, so put a 0 in. Okay? Now regroup them by the term. X squared, go with x squared. So AB, and over here there's a 1. Okay? Don't say 0, there's a 1. This one right here is here. 0, 0. Constant here, 0, 0. So be very careful. I match them up with the terms. So make sure you match them up. Make sure you match it up. Okay, so match it up. X squared, x squared. X to the first power, x to the first power. Constant, constant. Okay? Now once you have this, so make sure you label first equation, second equation, third equation. Now you're going to use these three equations, apply the elimination method or adding method. It is the same, just different vocabulary. So I'm going to take this equation. I'm going to bring it over here. Well, first thing is, the first equation, we only have AB, so we'll leave that alone. Here, the equation 2 and 3, it doesn't matter which one. Here, 2 and 3, okay? So here, if you look very carefully, in the first equation, there is no C. So for 2 and 3, we're going to get rid of C. Okay, so one more time. In the first equation, there's only A and B. But the second equation and the third equation, there is a C. So we're going to get rid of the C. So using the elimination process to get rid of the C, the rule is same value, opposite sign. Same value, opposite sign. Here's a 2. So therefore, I must multiply by 2. If this was a 3, then I multiplied the top equation by 3. Okay, and so on. So this is 2. So multiply the first equation by 2. Okay, if this was 3, you will multiply by 3. Since this is negative already, so it'll just stay positive. So the rule of elimination, again, if you remember, multiply the same number, make sure opposite sign. Okay, so elimination, same value, opposite sign. This is 2, 2. If this was 3, 3. Since this is already negative and this is already positive, so it'll just stay positive. One more time. Why are we eliminating the C? Because the first equation has A and B. Okay, it only has A and B, so C goes away. So now this side, C also has to go away. So just multiply 2 times 0, 0. 2 times negative 6, negative 12. 2 times negative 5, negative 10. 2 times C is 2C. So all I'm doing, I'm just bringing down the equation. That's all I'm doing. So this is this is this. This equation, since I'm not changing, stay the same, stay the same. Now eliminate 0, 0. Negative 12 plus 9, negative 3. Negative 10, negative 6, negative 4. And as you can see, C disappeared. Now label this as equation 4. You're going to use 1 and 4 to get rid of either A or B, your choice. You're going to use equation 1 and 4 to get rid of A or B, your choice. Here in our situation, I'm going to eliminate the A. So since this is 3, I will use 3. Same thing with the elimination rule. Same value, opposite sign. Okay, so here I have negative 3. I'm going to use 3. Since this is negative and since this is positive, this stays positive. Okay, again, where did this 3 comes from? Because this is a 3 right here. This is a 3. So I'm using the same value, opposite sign. That is the rule for elimination. Same value, opposite sign. Okay, since this is already minus and this is already plus, leave this 3 as positive. Now just bring down the equation. Bring down the equation. This one I'm going to multiply by 3. Where did I get this 3? From here. Why? Because I need them to be the same so I can cancel. Okay, so 3 times 1 is 3. 3 times A is 3A. 3 times B is 3B. Bring this equation down. So this is this equation. This is this equation. Okay, now cancel. 3 plus 0 is 3. Positive 3, negative 3 disappear. 3 subtract 4, negative 1b. I want the letter to be positive, so bring the negative over, so b is negative 3. Once you have a value for a specific letter, go back to all the other equations to get the other letters. Once we have an answer for a specific letter, go back to get the other letters. So I'm going to go back either 1 or 4. And again, I'm going backward. I have B already. Go back to 1 or 4 to get A. In this case, I'll just choose number 1. So I pick number 1. We know what B is. B is negative 3. Bring the 3 over, become positive. So 1 plus 3 gives me 4. Now we know what B and A is. Go back to either one of these equations to get the letter C. We already know what B and A is. B and A. So go back to 2 or 3 to get the letter C. Here I chose number 2 to get the letter C. To get the letter C, I chose number 2. Again, you can do 2 or you can do 3. It'll come out the same answer. Okay, so I chose 2, so I put A in, which is 4, B, negative 3. Do your algebra, becomes 9. So I have my A, I have my B, I have my C. Now take these 3 values, go back to the beginning, and plug in A, B, C. Okay, so take these values, A, B, C, and plug it back in here, A, B, C. So A here is 4, B is negative 3, C is 9. So this is the decomposition fraction, the partial fraction decomposition of this guy. Okay, one more time. This right here is the answer of this, okay, which is the same as up here. Okay, so be very careful on this lesson for partial fraction decomposition number 2. Case number 2. There are 4 of these cases, but for this video, we'll just focus on case number 2.